last year talking about limits. And if you recall, you ended the year talking about probably crazy looking graphs. For instance, this. A graph that might look like this. You guys are used to and have been for years and years and years been given a line. And I would say, or your math teacher would say to you, find the slope of that line. Well, if it's a straight line, all you need to do is figure out how much the y changes divided by how much the x changes. Big deal because it's a perfectly straight line. But what if I ask you to tell me what is the slope at, say, this point right here? What are you going to do? Because it's a curve, it's not a straight line. So this is where limits come into play. And what you should have talked about last year is you should have talked about, well, if I had a straight line, and this pen is really hard to draw straight lines with, so bear with me here. But let's say we had a straight line, and that straight line went through this point on the curve, and it went through that point on the curve. Well, you could easily find the slope of that line. But that's not what I want you to find the slope of. I want you to find out what's happening specifically right at that point. So, this line, does anybody remember what this line is called? When it touches the graph in 2 points, it's called a, starts with an S. Let's just come up with a bunch of words that start with the letter S now. It's called a secant line.
Secant line.
Do you remember? Okay. At least you remember. Okay, so this would be the secant line. So what you would be doing is finding the slope of the secant line. Well, you find slope. You guys know that you find slope by subtracting the y values and then dividing that by subtracting the x values. Y values, you know, go up and down. X values go straight across. So if you were finding the slope of that secant line, you would figure out how much is it changing to go from this point to this point, and then you would divide it by how much it's changing to go from this point to that point. Are you with me here? Well, that's easy to find. You guys can calculate that very easily, but like I said, if you are trying to find the slope at that point right there, what you need to do is keep bringing this secant line down. So you would then draw another secant line here, and you would find the slope of that line. Well, that's still not quite what you would want. So then you would maybe draw you would find the slope of that secant line. And then you would find the slope of that secant line. What you're doing is narrowing the graph in to find the slope of that point. But the problem is, at just that one point, your x value doesn't change at all. And if your x value doesn't change at all, the bottom right here is going to have a value of what? It's going to have a value of 0. And what happens when you divide by 0? You can't. You're going to have an undefined fraction. So that's when we need to start talking about limits. So I'm going to switch over here to my notes, and then this is where you guys need to start writing. So for example, let's say you have a situation where you have to graph x cubed minus 1 over x minus 1. Notice I'm telling you that the x value cannot be 1. Write that down, please. So if you were to sketch this, you would sketch it like normal. You could go to y equals, you could type in the numerator divided by the denominator, and then you could just start plotting points. But the problem is when you get to this value on the bottom, if you were to replace x with 1, you're going to have kind of like something's going to happen on your calculator. If you were to go to a table on your calculator, what would your table tell you?
Error.
It would tell you error. So what would you do there? So my suggestion would be to sketch the graph like you normally would, but you have to watch to see what happens when you get closer and closer and closer to that value of 1. Do these tables look familiar from last year?
Yeah.
have you guys create tables, and what you try to do is kind of narrow into this value of 1. So you're going to do the same thing. And it doesn't really matter to me what values of x you pick for your table, but typically when I do these things, if I want to figure out what's happening at 1, I look at what's happening just before 1. So in this case, I'm looking for what happens. I need to hold on. I guess we're using green today. Okay, so when you do this, what I would do is look at an x value of 0.999. Look at something that happens just before x is 1, and then look at what happens just after x is 1. So if the value right before 1, 0.999, gets you a y value of 2.997, and then you look just after it, 1.001 gets you 3.003. What do you think should happen when x is 1? You're probably going to get a value of 3. So, but we know that if you were to actually plug a 1 in for x here, are you going to get a value of 3? It's going to get an error. So, what does that mean to you? If you get an error there, but it looks like it's supposed to be getting closer and closer and closer to 3, what does that mean? Do you remember the word? Limits. Yeah, we're talking about limits. So, in other words, as you get closer and closer and closer to an x value of 1, the limit of the graph is getting closer and closer and closer to a y value of 3. So as x approaches 1, from left to right, f of x approaches 3. So if you were to graph this, and again I wrote the function down for you then, x cubed minus 1 divided by x minus 1 looks like this. So if you can graph this on your calculator, you can plot a bunch of points, you can get a nice pretty graph, but the problem is you guys know that when you have an x value of 1, you shouldn't have anything going on. What is this thing called? It's a break. It's a break in the graph. So your graph, if you were to follow it from the left and approach an x value of 1, here's your x value of 1, as you get closer and closer and closer into it, it's getting close to 3, even though it doesn't actually hit 3, you know it's getting closer to 3. Would you agree? What happens if you are coming in from the other side? You're coming in from this way. What's it getting closer to? 3. Again, it's getting closer to 3. So that brings me to my next point. We're going to start talking about limits. What happens as you get closer and closer to that value? So I'm not asking, now the difference between a limit and actually finding the value of a function is, if I were to ask you, what is the function's value, what is f of 3, you would have to put 3 into the function and get an answer out for it. If I were to ask you for what is f of 1, you put that x value in and you get an answer out of it. But when I'm asking you to find the limit of something, I'm asking you just to tell me what's happening as you get closer to that x value. It might actually not get you a defined answer, but the question is what's happening as you get closer to it. What number is it approaching? So if f of x close to a single number L as x approaches c from either side, the limit of f of x as x approaches c is L. Now L, what is L? Why is it L? It's the limit, but what does L mean? It just represents some number. You always get a number as your limit. If it exists, you get a number for the answer. In limit notation, the limit is written as this. What is the limit as x approaches c? Does this look familiar, you guys, this notation? The notation as x approaches c of f of x is equal to L. And then we're actually going to start replacing f of x's with real functions, and you guys are actually going to get real answers out of it in the end. Can I do what?
Right there.
Right there, okay. Do you guys need a second to get caught up on writing?
Yeah.
What is C? C is just a number. So I am going to ask you, what is the limit of some function as you get closer and closer and closer to an x value of 5, or an x value of -1, or an x value of 0? And you sometimes will get an answer and sometimes you won't get an answer. We will go over what happens when you don't have an answer. There's typically 3 situations when you're not going to get an answer. We're going to get into those probably sometime this week. So an example. What is the limit as x approaches 0 of this function? Here's your function. This is the function right here. And the reason this gets a little bit tricky is because when I put that 0 in for x, it doesn't really matter as much on the top, but it's always the bottom. Since this is a fraction, the bottom is what screws it up, because we could get what on the bottom? We could get a 0 on the bottom, and if we get a 0 on the bottom, the fraction becomes undefined. So, let's see what happens here. If I put a 0 in for x, I'm going to have 0 divided by the square root of, I'm going to replace that x with 0, plus 1, minus 1. Well, on the top we have 0, the bottom. Well, what is the square root of 0 plus 1? It's 1. What is 1 minus 1? 0. And we cannot do that. It's a big no. You cannot have 0. You cannot have 0 on the bottom of the fraction. So what happens, what we need to do is figure out what happens as we get closer to 0. Not what happens specifically right at 0. What's going to happen when we get closer and closer to it. So what you need to do is make a table. And my table here is probably a little bit bigger than you guys would need to make your table. But remember, we're trying to figure out what happens as the limit gets closer to 0. So probably start your table right at 0. We don't know what happens because we know we have an undefined function there. When x is 0, we have an undefined situation. So you need to figure out what happens right before 0. You need to figure out what happens right after 0. So really, I think the most important part is to figure out what's going on right here. Are you with me? Mm-hmm. So I looked at a number just before 0. So just before 0 are negatives. Would you agree? So try negative 0.0001, and then try something right after 0, 0.0001. And the smaller the value you try, or the value that you try, the closer the value to 0 that you can get, the better off you're going to be. So if you want to type in 0.000001, then do it. But you don't have to be silly about it, you know. Just pick something a little bigger, something a little less than that. So let's try that. Go to your calculators, go to y equals, type in type in just the function. Type in x divided by, now be smart about this, the bottom has to be separated by parentheses, so make sure you put parentheses around the bottom. When you type in your square root, a parenthesis is going to show up, so add one at the end, add a parenthesis at the end. So what you have is x divided by the square root of x plus 1, finish your parenthesis, minus 1, and make a table. And when you make a table, you should notice that at 0, it should say error. Does it say error?
Would you start it?
So then, go to table start, press second window, start your table right at this value. Start it at negative 0.0001. You should get 1.99995. Do you agree?
Yeah.
Now, if you didn't get that, there's a chance that maybe it wasn't typed in right. Maybe you forgot a set of parentheses or something. But you should get 1.99995. You had a different number? Do you have the bottom separated by its own set of parentheses, and then you have one here and one after the x plus 1?
How do you do the table set?
Press second window for your tables to set up your table.
Then what do you do?
And then start where it says table start. Set it to start at an x value of negative 0.0001.
And then
Is it working now? No?
I still got 199. There's no 5.
Oh, no, wait. Highlight the number. That's fine if it switches to 1e negative 4, that means the same thing.
Mine says negative 1 for the y. Yeah, for whatever that is.
If you,
Error. I don't even have a 0.
Okay, what's second table? What's the first number? Or second window, I like. What's the first one? Was this one?
Or negative 0.00.
Huh? Then what's your next number? Change 0.001. That'll be your table.
oh, yeah, one, you need
Start now.
You're going? Email from Monday.
No?
It doesn't matter, because you're just gonna be switching it all over the place, so it doesn't matter. Yep, I usually do mine right at one, you're just gonna go right back in and switch it to the number right after, so I wouldn't worry about the table counter. Alright, so there's a little bit of confusion with how you are typing in your equations because the yellow calculators are slightly different than just the normal black ones, so there's a little bit of confusion there. The yellow calculators are so fancy that when you type in the square root, this bar keeps growing until you're done. So it actually doesn't even put that parenthesis there, does it?
No, I put it.
Okay, so ignore that. You just have on the bottom x plus 1, and then you kind of step out of it, and then you do minus 1. So want me to come and help you? By the way, if you are using yellow ones, I still think you need to separate the bottom by its own set of parentheses though, okay? So make sure you're doing that. All right, so anyway, you go to this x value, and a lot of you are saying, I'm not getting the 5. Highlight that number. Get your cursor right on top of 1.999, whatever it is, and at the bottom of the screen, you're going to see 1.99995. It is a rounded value, but the real value shows up at the very bottom of the screen, okay? All right. All right, now, okay, so that's what happens right before 0. What happens right after 0? What happens at 0.0001? So how do you do that? Press second window. Again, you're going to have to go back into your table, and you're going to have to tell the table to start at 0.0001. At 0.0001. And again, you might actually have to highlight that y value so the real thing shows up at the bottom of the screen, 2.00005. 2. Okay. 5, 2. By the way, it doesn't matter. It does not matter what you're counting by on your table, because you're going to set your table to start at this number. You're going to write down what you get. You're going to go right back in, and you're going to tell it to start counting at it, or to start at a different number. These are the two things that you're concerned about. It's quick just to go back in, tell your table to start at a different value. Okay.
Like when we were in your starting class, we had this.
He just started somewhere and it showed us all of them.
It was usually like 0.001.
So he would tell you to start here,
And then
and
set
he
it.
would get it to count by something, so it would just have it all set up.
Yeah.
Okay. I'll have to think about what he was having you guys count by. But these are the two values right here that I'm concerned about. So you can quick do a table start here, change it to a table start here, write down the y values. I'll think about that and see what he had you guys counting by. Yes.
You don't have to change it to table start.
You could have put.
They're saying, I think.
Right, but he had to have had the counter,
Yeah.
the delta table. He had to have had that set at something so that you could quickly count.
0.001.
0.001 is what we said.
0.001.
Yeah.
Count by
All the
0.001s.
It
wanna
worked.
see it?
It worked every time.
You wanna
Yeah.
see
Yeah, and it does. See,
Okay, but hold on. That's fine, but was it just to go from here to here to here?
No, he made us do
Just
3
these
above
three?
and 3.
Or would it fill in this whole huge table?
Yeah.
There was a
A
few.
whole huge thing.
Okay. Try it, then do it. Then do that. 0.001.
0.001.
But if you're at 0.001,
You gotta look at it like.
if you're at here and you add 0.001, oh, it would get you to there, wouldn't it?
It just goes 0.003, 0.002, 0.001, then 0.
Okay. Okay. I'll have to look again, but okay.
It works good.
Are we okay with this though, you guys? Can I go on?
Yeah.
All right. Okay. So obviously, let's go down here. We're at 1.99995, and then right after it, we have 2.00005. What's it getting close to? Getting close to 2. Getting close to 2. So the limit, as x approaches 0, of x over the square root of x plus 1 minus 1 should give us an answer of 2. Give us an answer of 2. All right. Another example. F of x is equal to 1. F of x is equal to 0. But f of x is equal to 1 for any x value that is not equal to 2. But f of x is equal to 0 for any x value that is 2. How many x values do we have that are exactly 2? 1. So, in other words, this is called a piecewise function. Do you remember talking about them last year?
Yeah.
A piecewise function, I always think of it, if it's a piecewise function, it's broken into pieces. This function has 2 pieces. Sometimes they have 3 or 4 pieces to it, but in this case we just have 2 pieces. Yes, ma'am?
Can you scroll it up, please?
Yes, I can screw it up.
Oh no.
the value of f of x is equal to 0 when x is 2. So here's my y and my x-axis. I go to an x value of 2, and I know that the value of my function when x is 2 is 0. So I have a point right here on the x-axis. But then everywhere else, when x is not 2, what is the value of my function? It's 1. So here's a y value of 1. So all I have here is a horizontal line that exists everywhere at 1 except when I have an x value of 2. Okay? But my question to you is, find the limit of this piecewise function as x approaches 2. I didn't say what is the value of the function when x is 2. I want to know what is the limit. What is the value, or what is the graph getting closer to as we approach 2? So in other words, as I'm coming in from the right and when I am coming in from the left, what is the graph approaching?
2.
Well, as we approach our x value of 2, the graph is getting closer and